All right, 4, 5, and 6, the basic properties of logarithms. Keep in mind that logarithms are inverses of exponential functions, so their rules are also inverses. If I think about an exponential function, if I'm doing x to the m times x to the n, I get x to the m plus n. So with an exponential function, when I'm multiplying with the same base, I add the exponents. With a logarithmic function, if I'm adding my logarithms, I'm going to multiply the numbers. So common base, base 4, that must be the same. So the log base 4 of 3, the log base 4 of 7 would combine into the log base 4 of 3 times 7, so 21. If I think about my rules for exponents when I'm dividing, if I have x to the m divided by x to the n, it becomes x to the m minus n. So with a logarithm, if it's a negative, it ends up going to the bottom of the fraction. The log base 5 of 8 minus the log base 5 of something equals the log base 5 of 8/9. Well, the number on the bottom of the fraction is a 9. So the log base 5 of 8 minus the log base 5 of 9 equals the log base 5 of 8/9. When I subtract logarithms, I change it to a division. And on my powers, if I have x to the m raised to the n power, I get x to the m times n. What that's telling me with a logarithm is if I'm multiplying something times my logarithm, it can then become the exponent. So this would be log base 8 of 5 to the second power. That exponent can be multiplied by the logarithm, or if I multiply it, it becomes the exponent. Of course, I would want to simplify that. 5 squared is 25. So number 5, if I look at that one, I have log base 3 of 7 minus the log base 3 of 5. It's going to be the log base 3 of 7 over 5 then. Because I'm subtracting, I end up dividing by that 5. Log base 7 of what? Plus the log base 7 of 4 would be the log base 7 of 12. Well, I have to say what times 4 gives me 12? Oh, that must be a 3. And then this one, I'm saying, okay, the 81 has to equal, and this would become the exponent here, so 3 to what power? 81 equals 3 to what power? So I'd say, okay, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. I'd have fourth, so this would have to be the fourth power. Right, that exponent would go out in front. So 3 to the fourth power is equal to 81. And we're going to use this bottom rule a lot when we are doing logarithmic equations, where if we have an exponent, we move it out in front and multiply it by the logarithm in order to simplify and get our variable out of the exponent. One more of those. So on number 6, log base 7 of 2 plus log base 7 of 9. I'm adding my logarithm, so I multiply log base 7 of 18. Part B, log base 5 of what? Minus the log base 5 of 7 would equal log base 5 of 6/7. The first box would have had to be a 6. And then log base 8 of 25 equals 2 log base 8 of what? I'd say 25 is equal to what? To the second power then, right? This becomes this exponent. Well, 5 to the second power is 25. So that number would have to be a 5. So those are your basic rules for logarithms. If we're adding logarithms, we combine it into one expression by multiplying, subtracting logarithms by dividing, and that we can multiply a number times the logarithm, it would then become the exponent of our number.